Next up, dividing radicals, or A.K.A., otherwise known as rationalizing the denominator. So when we have a radical within a fraction, we cannot have a radical symbol in the denominator. That's not a properly simplified radical, or fraction for that matter. So we have to do a technique called rationalizing the denominator. And if you look at these examples here, they look pretty wild. But we're going to take it nice and slow. So when I rationalize these denominators, starting with this first one, first I'm going to rewrite this fraction here. That radical covers the entire fraction. I'm going to rewrite it this way. So now I have a radical in the numerator and a radical in the denominator. However, my rule states I cannot have a radical in the denominator. So to get rid of that radical, I'm going to multiply both the numerator and the denominator by square root of 7 over square root of 7. Because anything over any numerator and denominator that match each other is equal to 1. And by multiplying a fraction by 1, I'm not changing the value of the fraction. It's still going to be what it was previously. But I multiply across my numerators, and when I multiply across my denominators, my square root of 7 times my square root of 7 is, of course, square root of 49. A perfect square comes out to be just 7. Now I need to simplify. That's rule number 2 up here. Right here, gotta simplify. So I take my square root of 28 over 7, and I know that that square root of 28 has to be simplified because it contains a perfect square of 4. 4 times 7, like this. Square root of 4 is 2. I'm left with 7 over the whole number 7. Now those 7s don't cancel each other out right here in my simplified answer, because one is a whole number and the other is underneath a radical. Okay, but that's my simplified answer. It does not have a radical in the denominator. The entire fraction is simplified, and the radical is simplified. Okay, so we're going to do a few more of these so we get the hang of it. And there we go. All right, so next up I have 3 over the square root of 7. Once again, I cannot have a radical in the denominator. So I multiply both numerator and denominator by something equivalent to 1. So I have the square root of 7 over the square root of 7. And this will allow me to eliminate the radical in the denominator. I multiply my numerators together. And when I multiply my denominators together, once again, I have square root of 7 times square root of 7. And that works out to be just plain old 7. Now this is a properly simplified answer because I do not have a radical in the denominator, check. My fraction is simplified, check. And my radical in the numerator is simplified, check. Check, check, check. Next. Okay, there's a radical in the denominator, and I need to change that. So I multiply the whole thing by something equivalent to 1, so it doesn't change the value. And I multiply my numerators together. And then I multiply my denominators together. So square root of 2 times the square root of 2 is just plain old 2. Now take a look at what I have left here. That fraction is not simplified. That is not simplified. I can reduce the 2 and the 4. 4 divided by 2 is 2. So you can, if you notice, that 2 cancels, and I'm left with the 2 in the denominator cancels, and I'm left with a 2 in the numerator, which is just 2 times the square root of 2. I'm going to minimize that. All right, next up. I multiply the whole thing by a fraction that is equivalent to 1, so that I do not change the value. The goal here is to rationalize that denominator. In the numerator, I have 3 times 15, the square root of 3 times 15, which is 45. Okay, so I no longer have a radical in the denominator, and I have to simplify the radical that's in the numerator. So looking at square root of 45, I need to know the perfect square, the largest perfect square of 45. That's 9, of course. So square root of 9 is 3. And then I have square root of times square root of 5 in the numerator. In the denominator, I still have 15. And this will simplify. This fraction will simplify. So there's a 3, there's a 15, and that 3 will cancel, and it'll just be a 1, and or reduce rather, and the 5 will reduce, 15 will reduce to 5. So I'm left with square root of 5 over 5. That's my final answer. And I'm going to minimize all of this scratch work, because I'm running out of space. Next one, easy peasy. Square root of 64 over the square root of 81. Both of those are perfect squares. Square root of 84 is 8. Square root of 81 is 9. Is there a radical in the denominator? No. Is the fraction reduced? Yes. Are there any other radicals that need to be simplified? No. So that's it. done with that one. Right, next I have square root of 15 over the square root of 20. And the square root of 15 has no perfect squares in it. Square root of 20 does. But I'm just going to rationalize the denominator. Just going to rationalize. So now I have 20 in the denominator, square root of 15 in the numerator. And I can't do anything else with that. It's simplified the way it is. There's no radical in the denominator, check. The fraction is simplified, check. And the radical is simplified, check. So that's it. And this last one here, almost the last one, rationalize the denominator. So I have 15 in the denominator. In the numerator, I have 2 times the square root of 15 times 5. What is 15 times 5? 75. Now that can be reduced. So that's going to be 25 is the greatest perfect square root. 25 times 3. And then, stay with me here. Square root of 25 is 5. All that over 15. Then I have 10 times the square root of 3 over 15. I am not quite done. Goodness, I'm running out of space here. Minimize. Right. So here's where I'm at. Move this over here. Move this over here. Now that fraction can be reduced. I've removed the radical in the denominator, but my fraction can be reduced, the 10 over the 15. So 5 will go into 10 2 times. 5 will go into 15 3 times. So I'm left with 2 times the square root of 3 over 3. That was, oops. Goodness, I'm running out of room there. It's kind of hard to maybe I just write big. Okay, then we have 4 more problems here. I'm going to erase. I had the correct answer right there. That's not why I'm erasing. I'm just erasing so I have more room. But you can rewind the video and go back and check my work. All right, next up, 5 over the square root of 11. I rationalize the denominator. I'm doing it this way because the square root of 11 over the square root of 11 is the value of 1. And so when I multiply a quantity by 1, I am not changing its value. Okay, there's nothing further that I can do with the square root of 55. There's no perfect square that I can factor out of that. So my answer is simplified. I do not have a radical in the denominator, check. My fraction is simplified, check. And my radical is simplified, check. Next up, the 25, square root of 25 over 2. And I'm going to rewrite this in this way because it's just easier to look at. And then I rationalize the denominator. And then I'm going to move my work down here. This is kind of challenging finding proper space. You can see the next page, we have Pythagorean theorem coming up. That's next week. Okay, so I rationalize the denominator. I have 2 in the denominator. Square root of 2 times the square root of 2 is just plain old 2. And then the square root of 25, of course, is just 5. And square root of 2. And that's it. That's my answer. All right, the next one, square root of 4, which is perfect, over the square root of 36, which is also perfect. So that's going to be 2 over 6. Simplify that. That's it. That's your answer. And lastly, okay, I'm going to reduce this real quick. I have to rationalize the denominator, but before I do that, I'm going to rewrite that 20 as 4 times 5. That square root of 20. And I got 2 times the square root of 10. I'm going to rewrite my mess down here. Square root of 4 is 2. And then I'm left with square root of 5. And notice that my 2's cancel each other. And now I have square root of 10 over square root of 5. Okay. And move that over here. Now I have to rationalize the denominator. I am not done yet. Square root of 10 over square root of 5. I rationalize that denominator. So I have square root of 50 over 5. Now I have to simplify in the numerator. There's a perfect square hiding in that number. And that works out to be 5 times square root of 2 over 5. Ooh, look what happens here. This is embarrassing that I'm running out of space. But those 5's cancel each other, and my final answer is square root of 2. Okay, so we'll go over this in class also, and hopefully I figure out a way to have some more room. But that's it. Ta-da!